This video is about the functional group aldehyde. And as you can see in our lower left here, lower right, we have what the aldehyde group looks like. The aldehyde group has your carbon chain, so this is our carbon chain, and then you have a C double bonded to an O and then an H. Now, this particular group right here is called a carbonyl. And you'll see this frequently in the functional groups coming in the next couple of ones we're going to look at. So let's start with rewriting the carbonyl. So carbonyl is a C double bond O, and it can be in the chain, it can be on the end, wherever. Now in our aldehyde, because that's what we're working on, we're doing aldehydes as the group. And in aldehyde, we have the C double bonded O attached to a hydrogen. So the first rule is that the carbonyl is attached at the end of the carbon chain. So we're going to assume that this, even if we have, 4 or 5, and then we have our C double bond O, and we know that there's an H off the side here. It does not always get written, but this is going to be at carbon 1. When we do this, instead of it being a 1, 2, 3, 4, 5 carbon group in pentane, it becomes a pentanol. The numbering is the carbon's going to be at carbon number 1. And if the OH group is also attached to this line of carbons, if you have an OH group on there, you name that as a hydroxy. So that's an alternate naming scheme. If you have more than one functional group, we have a carbonyl, the aldehyde, and we have an OH group attached, which does happen frequently. It's a hydroxy branch. If you have additional carbonyls, meaning more than one, you're going to use oxo and the name di or tri. So there's lots of different possibilities. Carbonyls are pretty frequent in the molecules, the organic molecules. So you see them grouped up with other aldehydes and other functional groups, so that it's kind of hard to decide which one is going to be the most dominant in the naming scheme. So it looks like carbonyl, you have the Al ending, and then we can have all those other groups attached as branches. All right, let's take a look at these examples. We got this up here on the left. We have 1, 2, 3, 4 carbons. So this would be a bute structure, butane based. So we're going to change it to butanol. We only have the carbonyl group, the CO double bond, and it's we're going to assume that it's on the first position. So we don't number this any further. We're just going to call it butanol. If you look at the example on the right at the top, we have, we have 1, 2, 3, 4, 5. So this would be on the pentane branch. We have the carbonyl group, so we're going to call it pentanol. But we also have this OH attached. So we're calling this the first carbon here. This would be the second. So we're going to go 2, and because it's an OH group, it's going to be a hydroxy. So 2-hydroxypentanol. We're going to go ahead and just go straight down. We have this group. We have our carbonyl here. So 1, 2, 3, 4, 5, 6. So this is based on a hex. It has a double bond, so it's going to be a hexene, and it has a carbonyl, so hexenol. This we're calling the carbonyl at position 1, and the double bond is touching position 2, so 2-hexenol. And then this last one, looking at it, I see a carbonyl here, so 1, 2, 3, 4, 5 is my longest continuous chain, so I'm going to call this based on the pent. And it's all single bonds, so pentanol. I have 2 other groups attached to it. At carbon 3, I have another carbonyl, so I'm going to go 3-oxo. And also here on carbon 4, I have this CH3 group, so 4-methyl, 3-oxo, pentanol. So that one was a couple of extra things, all right? So again, we're just looking at the longest continuous chain, putting the carbonyl group at position 1, and then just naming it using the regular scheme that we have. You can have single bonds, double bonds, triple bonds. I didn't show any of those, but you could have them. And we also can have our OH groups as a hydroxy, and like up here, or we can have additional carbonyls as an oxo group. So people have been naming these compounds long before they developed the scheme that we're using. We use the IUPAC naming scheme, and that's what we've been learning all along. But there are some common names, and you'll see things like formaldehyde. That is an aldehyde with 1 carbon. You might see acetyl aldehyde. You might see propionic or propionaldehyde, and you might see butyr. These are just telling you how many carbons. So if you happen to see any of these root words, they're telling you how many carbons. They are also named differently with our normal methyl, ethyl, prop, but naming scheme that we've been going along. You are not required to use these, but I just wanted you to be aware that if you came across names using the name form, acete, propione, and butyr, that's what it meant.